Hello everyone. Thank you for joining with me. Myself, Somesh Shankar Konagalla. I'm a postgraduate student at National College of Ireland. Today, I'm taking about my research project of AI multi-sensor data fusion for predicting air quality pollution levels. Here, I'm gonna to explore uh, how the artificial intelligence can help to predict the air quality more accurately and fair uh, more accurately and fair using the data from multi-sensor and advanced models. Here, here my motto of this project is in the areas air pollution is a global health criticized. It causes the breathing issues and heart diseases and even permanent death. Cities uses something called air quality index that should be inform the peoples about the pollution levels. Uh, but here the issue most AQI system rely on the data from only one sensor and uses the fixed rules, and they should not capture how the pollution interact. For example, uh, how NO2 and PM2.5 together can worry about the air qualities. So, so I will show the real picture of the real picture of a lots. Here is the real picture of often getting lots of the air quality. And in this my in this my research in this project about my research questions are these: how can multi-sensor data fusion combined with the enable and deep learning models, and it will be enhance the accuracy and reliability of air quality classification compared to the traditional single sensor approaches. And here the next question is, can advanced deep learning models like transformers and sensor attention networks of say and there can be out there can be outperform the traditional classifiers in the AQI prediction? And my third question is, what are the expandable techniques and how can there be reliable to explain the model prediction and understand the fairness of the AQI classification? And these are the my questions of research. And here, about my research objective, here I am gonna to fix that by using the multi-sensor data fusion. This means combining reading from multi-pollution sensors CO3, NO2, and PM2.5. This to get a more complete view. Uh, then we using the machine learning and deep learning models to analyze the data. Here our goal is to predict AQI level more accurate and make sure that the models are transparent and fair. Uh, Here I'm gonna to in this data set. Here I'm using the data set from the Kaggle with the 23 of wearable this 23K city level records. Each center has the AQI reading of CO2, CO2, NO2, O3, and PM2.5. We cleaned it and the data using with the K and implement inclination for the minimum value, missing values. Here is the missing values uh, of the visualization, and minimum and maximum scaling for normalization and interaction terms between the pollutants like NO2 and PM2.5. And here I'm using the models. Here I'm using the three types of models. Three types of models. Traditional machine learning models here, random forest and XGBoost and light GBM. This will be greater for the handling structurized data. And here the deep learning models like CNN, LSTM are the hybrid models, uh, and their long, short, and for the temporal depending pattern, and transformers for the learning pattern across the futures. Uh, Here and one more model is that sensor attention network. This one is a special. This is not only for predictive AQI, and this also explained which pollutant matter mostly in the each decision. We also build a stacked assembly combining best model for the better accuracy. In the implementation, here I'm loading the libraries and machine learning models, and here expandability is that SHAP, and I loaded the data pre-processing data set here. Uh, I did the split the data set, uh, and here the model traditional models. And here the traditional models performed very well with the light GBM, uh, achieve the near perfect accuracy, and the stack assembly reaches the macro of F1 score over 0.99. And CNN and LSTM captured the long term trends and achieved the 93 percentage of accuracy. And the 93 percentage of accuracy here. And sensor attention network is hits the 92 percentage of accuracy with the better expandability. And here I use the metrics like accuracy and precision and recall F1 score, and here you see ROC for the class imbalance, and they used the cross validation to ensure the models were reboot. Uh, Here is about the expandability. Here we use the SHAP. SHAP is nothing but shapely additive explanation to show how the pollutant affect the model's predictions. For example, here PM 2.5 has the biggest influence on the poor air quality, on the air quality. Interaction between here NO2 and O3 were the strong indicators of the unhealth categories. Here, sand model assigned attention weight. It will be highlight what the pollutant matter for the production, make it most interpretable and fair. Uh, and here, these models can be helps like helps like power real time helps like power real time air quality monitoring systems for the cities. For the city, and this will be sent and here this will be sent. And here this will be send the alert to the peoples during the uh, dangerous air condition, and it helps the policies makers the plan for the green zone or manage the traffic, and this will be used in the mobile apps or in LOT devices for the personal air monitoring. And this is more just this is more than just academic, and this will be particular scalable and needed. And here is the limitations for my work is that uh, and here is the limitations of my work is the dataset was a static, no real time sensor or the satellite feeds. The transformer models does not perform well because it's a lack long sequence. But the features is brings to the next step, including using the lifetime series data from LOT and satellite, and it will be developing these models in the smart cities, building a hybrid AI physical models for the better real world accuracy. And coming here is the conclusion. I'm gonna to wrap up. We build a system that use the AI to predict a quality, accurate, and fair. We combine data from multi-sensor, and applied deep learning and made it expandability. Our models can be support real-world applications that protect the public health. Here is the reference. Uh, Here is the reference I used throughout the project. Uh, and this is about my project. Thank you for listening. If you have any questions, I do be happy to answer them. Thank you, sir. Thank you, Professor.